Okay, continuing to work on the UNSW 2024 Integration Bee. I've skipped all the way to round 2, problem 4. We have the integral from 1 to 6, natural log x plus 1 times x to the x dx. Okay, the first thing I notice here is just that we've got x to the x. We don't really like that very much. I think I want to deal with this part first, just because with the base not being e, this is going to be a problem. What I'm thinking here is that somehow this ln x plus 1 is going to be related to the derivative of this. So I'm actually going to jump right to a u substitution, calling this my u. So I'll say, we'll just set u equal to x to the x. But before I take the derivative, let's just rewrite this. Because for the base, what I can do with x, I can write x as e ln x. And then if this is x to the x, I can just use exponent properties on this and rewrite this whole thing as e to the x ln x. So we'll just put this in here as our value for u. Next, what I'll do, let's just erase this and take a derivative over here. So for our du value, we'll use this when we take our derivatives. So first we're going to have ex ln x, but we need the chain rule. We take the derivative of this, we're going to need the product rule. So doing that, derivative of x is 1 times ln x plus, then for the second part of this, we'll keep the x and take the derivative of ln x. That's going to give me 1 over x dx. But then over here, x times 1 over x, that's just going to be 1. But then let's just rewrite this whole thing to get like a clean version of it. So here we just have, this is just going to be ln, I'm going to take it out of order. This is going to be ln x plus 1. Doing this in reverse, ex ln x, I can write this as x to the x dx. But then what you notice here, this value for du, this is actually the whole integral. This is everything right here. So this is our du. So what I can do is go ahead and make this substitution with the whole integral becoming du, but I just need to update my bounds. So first, we'll plug a 6 in here. We'll use this version. So here we plug in 6, we're going to have just 6 to the 6. And we plug 1 in here, we have 1 to the 1, or just 1. Then we can just go ahead here and integrate du, or 1 du. This is going to be u, and we just need to evaluate it from 1 to 6 to the 6. Plugging this in, we're going to end up with 6 to the 6 minus 1. And I kind of like to leave the solution in this form, but UNSW did multiply this out. I actually forgot the value for 6 to the 6, and I was trying to see if I have a quick way to multiply this out without using a calculator, because that's boring using a calculator. Well, I can rewrite this as, I can write 6 to the 6 as 6 cubed squared. 6 cubed is going to be 216, so we just need to multiply out 216 squared. Now, a quick way to do this is just square the first number, so 2 squared is going to be 4. Then 2 times 6 is 32, double it, we get 64 here. Then square the last term, 16 squared is 256. Line it up this way and add it together, and we get for this 46656. But I need to subtract a 1 here, so my final solution, this is going to be just 46655. Okay, so there you have it. Good problem from UNSW 2024. Thanks everyone for watching. Have a good day.